Okay, so we're going to be looking at the Brown book tonight. Ooh. So if we go to chapter 3, and
I didn't even get that one out today.
I know. And in chapter 3, it talks about this thing called linked lists. Now, the first part of the chapter is this thing called singly linked lists. Next week we're going to talk about doubly. But singly linked lists. Well, first of all, let's talk about objects. And for those of us who remember the latter part of, well, probably all of chapter, or all of CIS 155, we cover a lot of objects. So objects are things, and they have methods, they have instance variables, they have a whole bunch of stuff going on there. So basically what an object is, it's a thing that holds data and also can execute things. So that's basically what that is. Well, if we need to put a bunch of objects together, and they need to be basically tied to one another. Again, think of going across country in a car, and we need to go to this city, this city, this city, this city, this city. But we have to go from this city to the next city, to the next city, to the next city. And we really need to pick up something in each city. So we can't really bypass these two cities and go on to that fourth city because we still got to get something from the other two cities. So that's kind of what a linked list is. So it's kind of this thing that we have to go from one object to the next. And those objects are called nodes. And a node again is just an object that is linked to another object. A great example is the drawing up here. It shows LAX, MSP, ATL, and Boston. So it's basically showing those three cities connected together. Now, with a node, there's a couple of things that it needs as well. Number one, it needs to know which one is the beginning and which one is the end. And when it's the beginning, it's called the head. When it's the end, it's called the tail. There's also another piece connected to it as well, and that is a link or an ID of some sort that points to the next node. So there in the figure 3.10, it shows the head, which is LAX, and then it basically, inside of this little box right here, it says, hey, I know where the next address of the next node is, and that's what that arrow is pointing to. And then MSP is pointing to ATL, ATL is pointing to Boston, and then Boston's pointing to nothing, which basically says this is a tail. And since we only go one direction, we call that a singly linked list. This arrow is called a link. Otherwise, it can also be called a pointer. It is pointing to the next node in this particular linked list. Now, if we were to look at this in Java, this is where it gets really kind of complex, is we basically would develop this class called a node. We would have our, in this case, we've got a instance variable called element, which is a string. And then I've got a private node next, which is, it's a node. Notice it's basically declaring itself as next. So this public class node, we're inside of it, and we're declaring something from node, so it seems kind of weird, but yeah, we can do those sort of things in object-oriented programming. So then I say public node, which is my constructor, and I got string s and node n, so I'm passing in my string. Now, does it have to be a string? No, it can be whatever you want it to be. So it can be whatever stuff you've got going on in a particular class. Where I take element is equal to s and next is equal to n. So now what I've got is I've got the data that goes with this node, and then the next is pointing to the next node. I've got my getters and I got my setters, and that's pretty much all there is. Well, since this first one is created, there's nothing pointing to it, so it knows that since nothing is pointing to me, I'm the head. And if I'm not pointing to anything else, I'm the tail. So the very first time we create a node, it's not going to have anything pointing to it, it's not going to be pointing to anything else. So it's going to be a single node sitting there, and it's going to be a head and a tail together. And when we start adding other nodes with the pointer pointing to the next node, then life is good. Now, if we were to, now we can insert new nodes. I'm on page 123. We can insert new nodes anywhere in this linked list. Now we have to be very, very careful. Adding a new head, that's okay, and adding a tail, that's okay as well. But to add a node smack dab in the middle, it takes a little bit of finesse. And what I mean by that is this, is let's say I have these nodes right here. And they're pointing to each other. So here's what I want you to think about. I want you to think about there's a current of water that's basically flowing down and kind of pulling these guys. These are all attached together, okay? And this lead guy has the motor. And this lead guy is basically going along, towing the other three nodes with it. If I wanted to insert a new node right here, I can't just disconnect this rope, or guess what happens? We lose those two other bolts. So here's what I have to do, is I take and I create a new node. Come on, work with me here. So I create a new node, and then I attach it to this node, and then I change the pointer of this guy to this node, and then I cut the rope. And once I do that, boom, this little boat right here will slide right in place, and life is good. Well, same thing in Java world. If I disconnect those two nodes, they're gone. We can't reconnect them. It doesn't know where, it doesn't have any numbers, it doesn't know what's going on, and they're basically just kind of get lost. So when we want to insert a new node, right smack dab in the middle, we have to connect it to the node I want to connect it to, then detach the rope from the other one and attach it to the end of that node, and then basically life is good. What if I want to delete a node? Well, what I would do is the same thing. So let's say I've got my nodes sitting here. They're all attached to each other. And I want to get rid of this guy right here. Well, the very first thing I have to do is I have to take this guy and point it to this guy. And then I execute by cutting that, and then cutting that, and then that guy doesn't disappear. It's just no longer part of the linked list, and it just basically just floats off wherever it basically floats off to. Okay. If you remember from 155, we do have garbage collection, and garbage collection will come along every now and then and go, who are you? I'm so-and-so. Are you part of this program? No, I used to be. Okay, I'm throwing you in the trash can. And it picks them up, throws it in the back of the garbage truck, and it goes on. So it's always going up, looking at data, going, are you attached to this program? If you are, I'll leave you alone. But if you're not, you're going in the dumpster. Okay? And so that's kind of what happened with that situation there. So when we're dealing with linked lists, we do have set next. We do have different methods that are available just for linked lists. So I should say we have to code for them. So I would have set next, tail.set next, and so in this case here, I want to basically take, I've got MSP going to Atlanta, then going to Boston. Boston's a tail, and I want to add MIA as the tail. So I would say make a new node. So make the new node, which is MIA. I would basically have that set to the no object. So that's kind of the key there. Like, so let me just back up a little bit. I'm going to go over here to my drawing. This guy has to point to something. Now what it's going to point to is null. Okay. Same way with this guy. Has to point to something. It points to null. And when it's pointing to null, that tells the linked list that that guy is the tail. Okay? And when we have nothing pointed to the header, we know that's the head. What's that?
When did you use null before? When
I think we've done a check with null. It's the word NUL. So if we look back at the book, it says v.setNext. So v is our new null. Our new node that we're creating, and I'm going to set the next equal to null. So that's what's going on right here in the second line. I've got MIA. I'm setting the next equal to null. Then I would take then the mark the variable tail, point to a new node. So then I would take Boston and point it to MIA, and then I would increase the size of my. Now that's another thing we have to do with linked list, is we have to manually take care of the size. It's not like an array. We have to basically add to the size, and so we would basically say size equals size plus 1, which is our increment. And again, if I want to remove, so here's kind of the algorithm we would use. This is if head equals null, then indicator error. So we basically would say, so if the head is equal to null, that means if the head's pointed to nothing, our linked list is empty. And then I would say, I would go ahead and, well, in this case here, we're just removing LAX, which means that we would remove any pointer to the MSP node, and would basically just disappear.
I'm having a school moment. No class next week, right?
We are having class next week. There's class weeks next week. The week after is no class. I will send out a reminder email as well. Okay, so linked lists are kind of a different beast. It's kind of like an array, but it basically gives us a little more power. It forces us to go through them one at a time. I cannot skip around. With an array, I can actually go, with an array list as well, I can go directly to this guy, I can go directly to this guy. So think of a linked list as kind of like if you remember the old cassette tapes. If you want to listen to song number 2, guess what you got to do? You got to fast forward through song number 1 to get to number 2, or let number 1 play through.
So this was a cassette tape.
Right. Right. Whereas our CDs are kind of like array lists, where I can actually go and jump around to each one that I want to go to.
Yep, and don't you dare cut a tape without, connecting it to something
Right.
else.
This is arrays are nice for simple for storing things in certain order, but they have drawbacks. They are not very adaptable. For one, since we have to fix the size of n of an array in advance. Okay, so again, we're thinking of an array. Array, I have to basically say it's going to be this size. It can't change. There are other ways to store a sequence of elements, however, that do not have these drawbacks. In this section, we'll explore the importance of alternative implementation, which is known as a singly linked list. A linked list in a simple form is a collection of nodes that together form a linear ordering. the follow the leader type of a idea. So it might seem strange to have a node reference. What's that?
Sorry. Conga line.
Yeah, conga line. Okay. Likewise, moving from one node to the other, following the next reference is known as link hopping or pointer hopping. Again, we have a head and a tail. So again, I don't want to dwell on this too much, but just kind of get those concepts down as far as what a linked list is, what a node is, and those types of things. Okay, next week we'll get into doubly linked lists. That sounds even more exciting than whatever. Okay, so we're going to jump over to the Watermelon book again, and we are going to cover chapter 12. Chapter 12 is kind of, I like it because it allows us to start writing programs that people can use. Okay, it's actually we're going to develop a GUI interface, a graphical user interface that basically is now usable. Okay, so
does what we just learned have anything to do with anything else we are doing tonight?
No.
Okay.
I'm just trying to throw data structures in there since this is a data structure class. So, and Donna said make sure I cover. So in the past, I've covered the Brown book a lot more, and people have walked away scratching their heads. But since this class is transitioning from data structures to advanced Java, I'm trying to get a blend of both for this class so that we can kind of make that transition. Okay.
Because I'm scratching my head a little bit. So.
Right. Well, again, that Brown book, if you look at it, it will make your head hurt trying to figure out some of those things because it really is a very heavy-duty math book with Java mixed in. I mean, it's even tough. It would be tough for me to try to write some of those programs. And they talk about some really advanced things that not even this book gets into. Okay, so the first thing we'll talk about is this thing called the Abstract Windowing Toolkit, or what's known as the AWT. And what it does is it has some different classes and things. Remember how we've had like the java.io, we had to import that? Well, we also have to import this Abstract Windowing Toolkit, which is known as the Swing class, so we can utilize some of these different graphical user interface. If you look on page 756, it talks about some of the different components we have. We've got labels. Labels are just that. It's just text. We cannot, people can't type in it. We can't change it dynamically. It's just there to display text. We have a text field. We have a combo box. Now, a text field is a text box. Our users can enter data into it. A combo box is basically a box that has a whole bunch of data in there. We can select things from that box. And the nice thing about combo boxes is it's drop down. You can click on the little arrow, it drops down the box. Check boxes, we can check some, all, or none. Radio buttons, we have to select one of them. If you select one, it deselects the other one. And I talked to some of these kids today that have never seen one of those in a car before. That's what we had to deal with back in the 70s and 80s, even the early 80s. We have a slider. If you look up there on the what is that, table 2-1 or figure 2-1, 12-1, sorry. Down the lower right, that's a slider. I can actually slide that.
That's a dial.
No, it's a slider.
Yes, but it's your dial.
Oh, right. On your radio dial. And then we have a button. So at the very bottom of that picture, we've got the close button. Okay? And so we have to basically write code for each one of those different components. So we've got the JFC, the AWT, and the Swing. These are all things that we have to import into Java in order to get those things to work. So, so the very first thing we want to do is create a window. So I'm going to go ahead and open up Eclipse while that opens up so that I can discuss some of the different components. So the first thing we need to do is create a window. Now, a window is just that. It's basically, it's a box that has a title bar. The upper right hand corner, we've got minimize, maximize, restore. We've got the close button. We've got all the stuff that a window has. Upper left has a little icon. That's something we can actually change. And then we have the sides, the four sides, and we've got a background color. Well, when we bring up a window, it's going to have just default. But the one thing we do have to do is we have to make sure we tell it the width and the height of our window. Okay? So if we look there on page 759, this is this one we're going to open up here in a second. First thing you notice at the very top, it says import javax.swing.asterisk. And that says it wants me to basically use everything that's inside of the the java.swing, which is a whole bunch of jar files and class files and things that are available to us. We create a class called showWindow. Inside there I got my public static void main, which is my executable one. And then I've got a constant called window width, set to 350. Another constant called window height, set to 250. And then I've got JFrame. So JFrame is one of those classes that's inside of the javax.swing. And it's a special class. It's the guy that basically has the window. So it's kind of the big picture thing. So I'm going to create an object called window, which is a JFrame. I have to instantiate it as a new JFrame. The parentheses are empty, meaning that the JFrame allows for a no-arg constructor. Down from that, I now take that window object, and it has a method called setTitle. And inside of there, I type in the phrase, a simple window surrounded by double quotes. So that is a string. Then I've got window.setSize. And there I've got window width, comma, window height. So that's where it takes the 350 and the 250 and plugs it in. And again, those numbers are in pixels. Then I've got window.setDefault close operation, jframe.exit on close. So what we have to say is, hey, how do you close this guy? How do you stop this program from running? Well, if somebody clicks on the X in the upper right hand corner, that's basically what happens there. It says, if that happens, I'm shutting the program down. And then at the very end down there, I say window.setVisible true. So what happens at that point, the window displays on our screen. So the one before that was a set default close operation. That's just saying the way to close this thing down is the X in the upper right hand corner. So oh, come on, Eclipse. Show yourself. There we go. So I'm going to create a new Java project. We'll call it Chapter 12. Oh, already got Chapter 12. What do I have in there? Okay, I've got some stuff. So, So, here I've got show window. Double click on it. Here's what it looks like. We just went through the whole thing. When I run this guy, watch what happens. Ooh, that's it. All there is. We created a window. We said display it. Notice the title in the title bar says a simple window. We've got our minimize, maximize, and our close button. And again, now if I click on this X, the set default close operation just basically executed and it closed that window. So, not too exciting, but nonetheless, So that just basically shows us how to create and basically create a window. Okay. Now we're going to open up Simple Window. And Simple Window, here's what that guy does. It basically creates a class, Simple Window, that extends JFrame. So instead of instantiating a JFrame, we've just went ahead and extended it, so we have our own class. And then I've got public simple window, okay, which is our constructor because it's got the same name as our class. And there's my window width, my window height. I set title, I set size, I set default close, and I set visible. So where is set title? Again, that's inside of the JFrame. Since we extended it, that means all the stuff we have access to. Okay? But how do we execute this thing? Well, if we scroll, we can't really. You have to use Simple Window Demo. So if I go to Simple Window Demo, this is my public static void main, and this is where I create my object, my window, which is a simple window, and basically instantiate it as a new simple window. Nothing in my parentheses, which means the constructor is a no-art constructor. And when I run it, I pretty much get the same exact thing. And there's my window. Okay, so both those did the same thing. One way basically created a new class, which extended from the JFrame. The other one just went ahead and created a new object from the JFrame class. Either way is going to work. Now, if we look at the next one, it's called Embedded Main. And what we're going to see is it looks identical to the last one. I've got Embedded Main extends JFrame. Here I've got my constructor Embedded Main, and inside of that I set my title, I set my size, I set my default close operation, and I set visible equal true. The only difference between this one and the previous one, there's no separate class to execute this guy. If we scroll down, look what it has. It has its own method called public static void main. And what does that guy do? It says I'm going to create a new class, embedded main. The object's name is EM, and it's a new embedded main, and that's it. Because the constructor is doing all this work, displaying the window, that's all it's going to do. And since this is public static void main, that is the only way that this thing can execute, by running it inside of Eclipse. So if I run it, same exact thing. So again, 3 ways to basically execute this guy. So now what we want to do over here on page 765 is we want to start adding some controls to this thing. We want to add a label, a text field, and a button. And probably the easiest way to do it is just bring it on over. So I'm going to bring over the kilo converter. Okay, so here's the kilo converter, and it extends JFrame, but now we've got some new pieces and parts we're creating. We're creating a thing called a J panel. We're calling it panel. We're having another object which is a J label. We're calling it message label. We've got another thing called the J text field, and we're calling it the kilo text field. And then we've got a J button. So those are all classes, all things that we are creating things from, and they're all part of the javax.swing. Okay, so it's kind of like, this is kind of like a string, So I'm creating a new object called panel. What's its data type? It's a JPanel, JLabel, JText, and JButton. Here is my constructor called KiloConverter1. Here's where I set my title, I set my size, I set my default close operation. Then I have something called BuildPanel. What is BuildPanel? That is a method down below. So notice we've got private void, that means it's returning nothing, and nothing's being passed into it. We've got message label. What's a message label? That is a JLabel. That's equal to new JLabel, enter a distance in kilometers. Okay? So here we are creating an object. Down here we're actually instantiating it. Kilo text field is equal to a new text JText field 10. What does that 10 mean? That means that that text box is 10 characters wide. So we set the width. And then I create a button, and I actually put the word calculate. So the button will have the word calculate on it. And then I say panel equals new panel. And then, so now what is a panel? Think of a panel. So we've got the window, but we can't just put things in the window. We have to add a panel first, and the panel is where we can add the button. We can add a label. We can add a text box. And so that's what we do down below. We say panel.add message label, panel.kilo text field, and panel.add calc button. So now we've added the panel, we've added this stuff to the panel. Well, then what do we do? Well, we've added to the panel. Where's the panel at? Well, notice the next method inside of our constructor is add panel. Add panel. So I come down here to the where's that? That must be
whether it's right or
well, okay. Okay, so the add is part of the window, and it says add the panel. So it adds the panel to the actual window itself. And then it says set visible true, and then it will display that window with the panel. The panel is not anything we can see. It's just a container that holds the button, the text box, and the label. So we set that guy to true. So let's see what it looks like. We run it, and sure enough, there it is. Whoop, I just closed it. Oh, come on. There it is. It's actually resized it by accident. So it comes up, and it says enter distance in kilometers. Here's our text box. It's 10 pixels wide, or 10 characters wide, I should say. And then there's my calculate button. Now I can type stuff in there, and I can click calculate. And guess what? Nothing happens. Why? We don't have any code. Yeah, we don't have any code behind it. So again, when I click the X button, that's when this set default close operation kicks in and it exits the program. So here's my constructor. It sets a title, sets a size, sets a default. Then I've got my build panel. The build panel then actually gets those objects, the JLabel, the JText field, the JButton, and adds it to the panel. And then we have a brand new panel. It has all that stuff in it. And then I click add the panel, which adds it to the window, and life is good. Any questions? Okay.
But you should know, I think you have a drive that is severe, whether it's like anything.
What was there?
Cleo is coming our way.
Okay. I'm about at the end of my video recording, so let's take a break and we'll come back.
That's what that time is. If you're